Hello, everyone, and welcome to a new show on the routing loop. Um, I'm Alex. I'm a networking specialist solutions architect at AWS. And here we are again, gathered together to talk about one of my favorite topics, which is VPC Lattice, Browser controller, all the good stuff. So, for those of you who are old friends of the show, and I already see a bunch of you here. Hi, Dominic. Um, Hi, X1 Autumn. Thanks for joining us. So, for those of you who are old friends of the show and are joining us every Thursday here on Twitch, I don't think anyone needs introduction on what we're talking about here on this show. But if you are new, the Routing Loop, as its name stands, is a Twitch show where we come together every week and we talk about AWS networking and content delivery things, services, architectures, features, launches, all the cool stuff that's happening in this space. Now, you will argue probably, and hello, Ken, good to see you. You will argue probably that, hey, EKS, Elastic Kubernetes Service, Gateway API controller, these are kind of not like networking things, right? Are they like application things? Stay tuned with us. They are actually very, very tied to networking. So we're going to be diving into all of this today. However, before I go rambling around more around all the cool things around Gateway API controller and Lattice, I have two guests with me today. Satish, Pablo, do you want to go ahead and introduce yourselves?
Great. Hey, thanks, Alex. Good to be here. I'm the product manager for VPC Lattice, so looking forward to this.
Yes, Satish is the person that I stress out the most on AWS side. I think he already had nightmares with me pinging him on Slack on like, when are we going to have this feature in Lattice?
It's all good. It's good stress.
Good stress. Okay, I don't know if there's such thing as good stress, but let's keep it to that. Just as a reminder, we cannot talk about roadmap here on the show, but we can slightly hint about things that we see as important to all of you, and we highly encourage you to put all those things that are important to you in the chat. So we have the chat right here. We're here to answer your questions. We're here to hear your feedback as well. So please do use the chat. With great power comes great responsibility. So use it wisely. Pablo.
Yep. Hello, everybody. Pablo Sanchez, a networking specialist solutions architect based in Madrid. You can see a little bit of the city from here.
Yes.
So yeah, nice to be here again.
Nice, awesome. Well, it's still daylight in Madrid. Like, what time is it?
Give it 30 minutes. It's 8 p.m. So give it 30 minutes, but we're good. We're good.
8 p.m. Well, I highly appreciate the fact that you've joined us today on the show. We should have had a set of different guests today, just so you all know. But all things are good. We're here and we're ready to talk about these cool topics. Now, before we dive right in, let us know in the chat if you've heard about the Gateway API spec, if you know what that is. If that's completely news to you, let us know. That's also good. If you've already heard about it and you're considering using it, let us know. And if you are already using it, also let us know. Ken, I see yes. Yes, as in yes, using it. Yes, considering using it. Yes, you've heard of it. We see X1 Autumn. I heard of it, tested it with Cilia, not the Lattice implementation. Cool. So we're gonna have some cool things to talk about today. Awesome. Yeah. So let us know in the chat. Pablo, you mentioned you're joining us from Madrid. I'm here joining from San Francisco, and it looks like I'm in a box. I'm not in a box. I am in an office. I usually am at home and I have my nice background, but today it feels like I'm in an interrogation room. But yeah, it's sunny outside, nice. So it's a good day Good day for science. Very interesting, Ken. See, me rambling actually helps us uncover interesting things that you folks are thinking about and letting us know in the chat. Ken, you know about it, but hurdles to implement. Would love to hear more about those and talk about them. But before we go into the super depth of this, let's see what we have prepared for today. Satish, can I bring your presentation up? I think you have some slides for us.
Yes, I do. Yeah, thank you.
Awesome. Oh, so take it away.
Great. Thank you, Alex. Looking forward to the discussion with all of you. Thanks for attending. So today it's about talking about the Gateway API, particularly focused on our ALB and Lattice implementations. But before I go in there, I'm talking about why Gateway API to begin with, right? What are the reasons for Ingress APIs and et cetera to move to Gateway API? And then I'll share more details on the Lattice Gateway API controller itself, like what is the versions, what does it do, how is it built, etc. And then no pressure, Pablo, but then the demo for you to sort of show the real live demo on things.
Well, so just to let everyone know, Pablo is now praying to the gods of demo as hard as he can. So we can have that demo working. Any luck, Pablo? Any progress?
Almost there.
Almost there. Okay, we're all rooting for you. By the way.
Yeah. Yes. Yeah, we'll have plenty to talk about before that. While you get the demo ready. So the Ingress Nginx deprecation was announced, right? So the Ingress APIs, as you know, when Kubernetes started out with defining these APIs for all sorts of networking controls and routing rules, etc. That deprecation was announced for the Ingress implementation for the Nginx controller in November. And there are a couple of links that we're going to share that give you that information. And so that's sort of the driving factor to go to the Kubernetes Gateway API. And what is the Gateway API from the Kubernetes side itself? It's a successor to Ingress. It's under active development. That means there's still some experimental stuff that they've defined, and we're adding support to it. The goal here was to sort of provide a very extensible role-oriented protocol configuration. So as those who are familiar with the Ingress APIs, other than the HTTP route, any multi-protocol support, you have to go and do a bunch of CRDs, and then anything around auth policies or multi-cluster deployments, you have to build it on your own with a bunch of different CRDs, and obviously depending on which CRD you use and which load balancer, the implementation complexity and the maintenance complexity of that ballooned, right? So therefore, the Gateway API sort of stepping in to sort of figure out how to provision the infrastructure and also support all the cool things around traffic weighting, the blue-green deployments, canaries, header-based matching, etc. The more important. Yeah.
Before we move further, I've heard some acronyms, and me as a layman networking person that has no idea about what these things are, I have to admit that at the beginning I was like, I don't really know what this is, and I'm getting lost. So you mentioned one thing about CRDs. CRDs stand for Custom Resource Definitions, right? And they're the expressive way, like the API contract to express what you kind of want to do with your Kubernetes objects, right? Did I get that right?
That's right. Yeah, that's exactly right.
Perfect. And then I know that there's also the old style thing, the old school like Ingress and services are based on annotations, right? Like that's a different way of thinking about it, right?
Yeah, annotations are interchangeable. CRDs are when you need to go into more detail and sort of specify a specific application, and then now your implementation of that API underneath it, right, maps more cleanly. Annotations are a way to convey things to the outside objects, outside the Kubernetes stuff, to say, hey, this is what I am. When that object is created, the annotation sort of gives you the metadata. So the meaning of it, if you will.
Got it.
So that's sort of the construct, and the reason why Ingress APIs in the beginning, they evolved with just HTTP routes, right? And then as the complexity grew with multiple protocols around HTTP, HTTPS, and obviously gRPC, so they all had to be defined with their own either annotations or CRDs. Now, Gateway API sort of formalized them and said, it's easy way to sort of define them very cleanly so that the same manifest can now run in obviously multiple clouds and multiple different implementations, follow the same standards, so you get all the benefits of standardization. And the goal was to sort of merge the Ingress and the service APIs to overcome like the limitations, and the service API itself suffered from too many responsibilities, as in you overloaded the service itself with a lot of things, versus now the way, if I go to the next slide, the class itself, sort of the structure itself evolved to say, look, there are two personas here. There's a platform team that builds stuff around the networking, the provisioning the clusters, managing security, and then the developers themselves who go and build their routes and set up their CI/CD pipelines, et cetera, to go in there. So here, the structure evolved to say, the gateway class itself is a sort of maps to an implementation class, as in whoever's implementing that. And then you could have multiple of these cluster controllers in a single cluster too. So you could have mixing and matching across different gateway classes, depending on what you're trying to do. And the gateway itself replaces your existing load balancer, right? So this is what gateway sort of is meant to do. It's started out as Ingress right now. It will evolve to egress and other capabilities in the future, but today it's mostly focused on ingress into a cluster. It could be north-south ingress from the internet, or east-west ingress from other VPCs and clusters into the existing cluster. And then the HTTP routes itself are the actual definition of the service itself. So that's sort of the structure. And I know Ken has a question around.
Yes, but before we get to Ken's question, I do have one more thing. So before we get into the actual depths of the implementation and all that stuff, I want to get this our conversation here as close as possible to networking folks too, because historically our guild of network engineers and network owners has been quite remote and quite disconnected from like what application teams are doing, what these platform teams are doing with their Kubernetes clusters, and why do they need all of these things. And I think here, like these are my 2 cents of like why you should care. You, as in all of you here looking at us today and hearing this, why you should care about the Gateway API spec, and why you should care about the standardization, and why you should care about this role-oriented kind of approach to managing clusters and applications in a network. And I'll give you my 2 cents on it, and Satish and Pablo, you folks let me know what you folks think. But I think the fact that now the standard is bringing together or is defining fairly clearly what each of at each level, what the operator at that level needs to do, means that there is a very clean boundary and way to interact between network owners, which are kind of at the bottom of the stack, which from the bottom of the stack perspective is bottom of the stack has been the most important thing. Then there's the cluster operator piece, which is essentially that platform team. And then there's the application owner and the folks who are, for example, their own worry is, how do I get my application up and running? How do I get monitoring? How do I make use of all these features of the platform, right? So if you're asking yourself, why should I care? And why should I look at the session? That is why you should care. And that's why Gateway API is so powerful and important at this point, and the standardization around it is important. Does that kind of make sense? Am I on the right track here, Satish?
Yes, yeah, that is the exact reason to have that sort of role-based differentiation and also increase the velocity here, right? To be not have to have a lot of handoffs between security platform teams and developer teams. Yeah.
Cool. Awesome. And now you mentioned, and we're going to dive a bit deeper, Ken, into how like the gateway API controller looks for VPC Lattice and how the HTTP routes look and so on. But your question, totally acknowledged. I don't know, Satish, if you want to address it now, or we should wait until we get to the more in-depth definitions of and concepts around the HTTP route.
Yeah, let's get to the in-depth concepts, and then happy to go into that detail, Ken, and also want to understand exactly what number of pads and stuff is. So
yeah,
interesting problem for sure. Now,
there's one more question. There's one more question from X1 Autumn, and I have to admit that I have no idea what this is, so I have to go do my research. Does Gateway API implementation for Lattice also support parts of the Gamma initiative?
Yeah, the Gamma initiative is coming from the service mesh side, right? Like customers are asking for a service mesh level constructs being added to the Gateway API spec to increase the spec itself to do that. So that was spun off as the Gamma initiative to go and add these types of enhancements. So those are still experimental. So depending on the type of the initiative that's been going on for east-west traffic within that, you could say within the Lattice implementation, if you are running the Gateway API with a bunch of clusters acting in the same VPC in the same cluster, then that looks like a service mesh to us. And with the Ingress APIs, let's say the ALB in front of it, or with the gateway itself, Istio gateway, for example, if you run that as with the Gateway API spec. So short answer is depending on what the specific initiative is, we can go into those details. Jonathan.
Cool. I think we should absolutely do that. I think we should also have potentially a separate episode where we talk a bit about the intra-cluster more in depth versus cross-cluster and how to stitch all of these things together. We're going to touch on these today for sure for a bit, but if you folks want to dive more in depth into this topic, please let us know. We are working backwards on these topics from your feedback, so just let us know in the chat. Okay, last time I interrupted you, Satish, I promise.
Oh, not at all. This is all good. So in terms of the structure itself, right? This is what the Gateway API structure looks like. Like Alex was saying earlier, the clear delineation between who's providing the infrastructure, right? Which is not just the VPC cluster, et cetera. And then there's the cluster operators themselves that sort of figure out, okay, this cluster was provisioned in this VPC for this dev team, right? That's where the gateway level comes in. And then the developers themselves focus just on the TLS route, HTTP route, their specific application that they care about, or multiple applications that they care about. So this makes it easier in terms of, like, you can imagine when the deployment manifest is created, developers can just focus on their TLS routes. Before, with Ingress APIs, they had to merge their existing definitions and CRDs into a single manifest, versus now you could have a different manifest sort of running, creating different things, and then have that be very clearly delineated between the two, right? So that's the structure, and I'll go into in more detail. If you look at the existing Kubernetes objects, right, load balancer objects, in the Ingress APIs, it started out with layer 4 load balancing, very simple. When you say service types equals a layer load balancer, you get the layer 4 load balancing, right? So very simply, TCP-based load balancing as an NLB gets spun up in the load balancer controller today for the Ingress APIs. And then if you say Ingress types equals load balancer, then we spin up the ALB in the load balancer controller for you with the descriptions around having a layer 7 support for your services. So here you can see, based on the actual the spec, the rules, and the backend, think of these as what the API definition had before. But you also notice that here there's no, if you have to define any certificates for HTTPS services, et cetera, then you have to do CRDs and annotations, any auth policies, any other specific routing rules that you want to configure. That sort of changed in Gateway API, and that sort of gives you that additional capability already, and it supports multi-protocols, like I was saying before, layer 4 through layer 7. And then you have different ways of specifying the rules and the backend refs, parent refs mapping to the gateway itself, right? And so in terms of implementation, what happens next is the how we decide what data paths to create based on these, right? So if it was L4, sometimes we create a classic load balancer, sometimes NLB, depending on the actual CRD you told us in the Ingress APIs. And then if it's an Ingress, then they spin up the ALB in front of your clusters, depending on where they're running. And these are all still Ingress APIs, right? So you still have to do one cluster, single cluster at a time. And now with Gateway API being supported both on ALB and Lattice, you get the layer 7 and the multi-protocol support being fronting this way. So the data path that gets plumbed when we go through your manifest is the controllers that are running in the EKS control plane, and then spinning up these resources based on your definition. So that's what's going on underneath. Now, if you look at what we take this and the Gateway API spec and map to what happens in Lattice, right? So because this is critical to understand that the gateway class itself maps to the Lattice Gateway API controller. If it's an ALB, it'll map to the ALB controller. Now, the difference between ALB and Lattice comes in at the gateway level. In Lattice, the gateway itself is the service network. So because Lattice is also your load balancer, the gateway maps to the service network. So when you say service networks equals a test or service network per environment is what we usually recommend. So if it's test prod staging, then any VPC that's connected to it will have connectivity to this. And then now you define your HTTP route and say, hey, point to this service network. Then Lattice acts as a load balancer for you directly. There's no other east-west load balancer needed. That's the difference between Lattice and normal ALB-based deployments. And then HTTP route maps to your service. In Lattice, it's the Lattice service construct, layer 7 service that gets created. And then the target groups are your different backend refs, right? Like it could be multiple target groups based on blueprint deployments, canaries, etc. And then pods, your pod IPs are your targets. So the way this is working underneath is the Lattice controller that's running in the EKS control plane is monitoring the kube API changes. And then as we reconcile your manifest with actually what's running in the data plane, we go and look at, hey, new pods get spun up. So we need to go register those new pods as IP targets into existing target groups. Those target groups could be in the same VPC, could be in different VPCs. That's where the Gateway API spec gives you that multi-cluster ability as well.
So I am going to put my hat on of Alex 3 months ago before she touched this. Because now I know a bit more, but like 3 months ago, I didn't know. So let's see if I got this right. And I'm going to tell you a bit about my experience. First, for me, it was pretty confusing that Kubernetes services and Lattice services are actually at different levels. So that's an interesting one, because actually the Kubernetes service is a target group. So you get to see that the moment you go configuring the HTTP route, right? And you're like, okay, this is the actual target, is what I've defined as a service earlier. That's one thing. So keep in mind that the service on the Gateway API implementation is in Lattice is the VPC Lattice service. It's not the Kubernetes service. That just becomes a target group. That's part number one. Part number two, you mentioned one super interesting thing, and it took me a while to click in my head how this worked. But you mentioned that the controller is actually running in the cluster, and it's looking for those resources that are actually that it has to monitor, right? And it does that through the Gateway API spec. The moment you create, for example, your HTTP route, you're telling it, hey, like, talk to this controller. Like, this is the controller that needs to look for example, you have a new pod that's coming up and it needs to be registered and all of that. Did I kind of get that right as like a mental model of how things work?
That's right. Yeah. So the gateway class defines the gateway controller, right? So in your manifest, when you're saying a couple of examples later that I can show you, it says, if I can go back to the previous slide, maybe that might be the easiest one to sort of talk about how here you say in this gateway API version, right? And then here's my service network, parent ref's name. And that's where it tells you, hey, that's my gateway that I need to go talk
Exactly.
to. Here's the kind is HTTP route. You would define a similar kind as a gateway as well. So that's what is happening in this step when we create that particular service.
Perfect.
So the whole goal is to keep the very Kubernetes native experience, right? There's no other APIs to define. You define your deployment manifest. You are working with Kubernetes APIs. And so all of that is being translated into, oh, you are in the gateway class of Lattice gateway controller. So we're going to go create Lattice constructs, service network, service, etc. If you deploy this with ALB, it'll create the ALB level constructs, like in the next slide that I'm going to show you, which is exactly the same construct sort of mapped into what happens on an ALB, right? So here the gateway would be the actual load balancer, just like the Ingress API's load balancer controller spins up a load balancer. Here we're spinning up the ALB, and then the TLS, in this example, TLS route or HTTP route points to the listener, and then the service is the target group.
Yeah,
right?
That makes sense. There's a question from X1 Autumn, and I think this question sends us a bit to do a bit of whiteboarding. So what do you folks think? I can bring up my whiteboard because I think we need to clarify this a bit. And you folks let me know if you can see my screen, actually. The whiteboard is up.
Yeah.
Okay, perfect. Awesome. So let me see if I got this right. And let me see if I can answer, or we can all collectively answer X1 Autumn's question. So this is my VPC, right? My service network lives here. Okay, let's call it, I don't know, the dev service network, right? You could have many of these service networks, by the way. You don't have to have just one or just one per environment. Really important. Now, in my VPC here is where my cluster lives. So this is my cluster. And this cluster runs here the nice controller. I'm going to put it as a cube here, the Gateway API controller for VPC Lattice. VPC Lattice.
Yeah.
And this controller, you essentially tell it, hey, your gateway is this service network, correct? Are you folks still with me?
We are. Let's
okay.
see the people
We are.
comment section. We are
waiting.
Okay, you're waiting for it. Okay, perfect. So now here in my cluster, I have some pods. Let me see if I can draw some nice pods in here. Pod 1 and pod. I wanted them to look nice, but they're not looking nice. And this is my service, right? Service, like Kubernetes service. Okay, it's service here. Let's call it cart. Okay, because that was the example that that you gave, Satish, right?
Yeah.
So now this cart service is essentially something that when the moment you define an HTTP route, right, on this controller, like you say, I have an HTTP route. This HTTP route translates into a VPC Lattice service that is associated with the service network. So this is service network service association, right? You folks know about that. Okay. And the target of this is target group 1. It's actually the Kubernetes cart service. Correct?
That's right. Yeah.
Perfect.
And how do you call cart is what in the HTTP route itself, right? Yeah.
Perfect. So let's say that this is cart.api.example.com. right? This is the custom name. Now, if you go into the Lattice console, for example, you're going to search for card.api.example.com and you're going to see it there. It's going to have that custom name, and all will work. Now, if I have, like, does this part of this clarify a bit, X1 Autumn, around how a service is exposed from the cluster? I hope so. Now let's take the example where inside of this same cluster, I have another Kate service, payments, right? With its own pods in here, running pod 1 and pod 2. Now, if I define, again, I do the same kind of thing, right? I define an HTTP route, right? Exactly with the same controller. This is going to become another VPC Lattice service that's going to be associated with the service network, and that's going to point to this as a target group. Correct? Am I getting this right?
Yeah.
So this is going to be cart, and this is going to be payments. Now, how these services are accessed, the question comes. Depends on who wants to access them, right? Let's say, first option here is, let's say cart wants to call payment, right? If cart wants to call payment, it's essentially intra-cluster communication, right? I guess here you have a choice, right, Satish? Like, you can go just pod to pod communication within the cluster if that's fine, right? You can totally do that because, hey, you're in the same cluster, so it's fine. But if you take the VPC and you associate it with the service network, right? This is VPC association. The VPC association, you folks see here, there's a nuance. I'm putting arrows on these associations. The service network service association is something that allows a service to be consumed. The VPC association allows clients in the VPC to consume that service. So technically, cart in here, if it resolves to the DNS name of payments through Lattice, right? So to the Lattice generated DNS name, or your VPC DNS is configured as such, Lattice cart could go talk to payments through the service network, and that works totally fine. Now, the true power of all of this is if you have multi-cluster piece, and here's where we're going to get with this, right? Where you have VPC2 and VPC3, and you have a bunch of clusters here, and with a bunch of services that need to talk to each other. And it's really, really straightforward and easy to have all of these associated with the service network, right? With the right arrow here. And if you have service 5 in here, and service 6, and service 7, and service 8, all of these become associated with the service network. And they can be accessed, and also they can be clients. So they can call other services in other clusters. Did I get that right?
Yes, and just to go deeper, Alex. So to John Adams' question, right? So how does traffic come that is destined for cart, for example, coming from VPC3 in your example? How does that get to it? Because what is the target when there's no load balancer, right? That's the sort of the question here. So.
Good one. Yes. So here, let's say service 8 is a client, and service 8 wants to talk to payments, right? So our service 8 here wants to call payments. Now, service 8 is going to go do a DNS query, right, to the Route 53 resolver. It's going to get the Lattice IPs for payments, which is something like 169.254, et cetera, et cetera. So it's going to get the IPs back, and then it's going to create a packet. And that packet is going to go to the service network, right? The packet is going to be IP source, IP destination. Not actually, these actually don't matter. But you're going to have host header, payments.example.com, right? Which is the actual service that I'm trying to call. And Lattice goes in and says, okay, cool. What is your host header? Lattice does host header based routing, right? For layer 7 services. So it looks at the host header and says, okay, we need to get you 2 payments. Is payments.example.com a service associated with this service network? Yes, it is. So here's how, like, Lattice looks at the host header and says, okay, host header matches this service. So it's going to send that traffic to the target in the target group. And here's where the load balancer piece is, right? The Lattice service in itself.
Yeah. So yeah, that was part of John's question. I think he's asking another one where if it's public facing, target towards public facing applications. So how does traffic from the internet get into and then go back to this cluster where card is, for example? Right?
Here's the cool part. Here's where the 2 controllers come together, actually, the load balancer controller and the gateway API controller. And that's the cool part. And I think we posted here in the chat the blog post that Pablo and I published around here in the cluster. You don't have to have just one controller. You can have multiple controllers, right? So I can have also the gateway, the load balancer controller running. And I can say, okay, I also have here an HTTP route, the load balancer controller with gateway API support, right? An HTTP route for cart, for example, which means that I'm going to have a gateway here, and this is going to be an application load balancer. That's going to be my gateway. And then the application load balancer is going to target the same service here. But this application load balancer can take Ingress traffic from the internet, for example. It can be a public-facing load balancer. So you get to choose which services need to be exposed just internally for service-to-service communication flows. And for those services that need to be exposed externally, you get that ability to put the load balancer controller there and to have an application load balancer exactly as you had it so far with the Ingress spec. Does that make sense?
Yeah, that's
John.
That should be the question. Hopefully, let us know if that addresses the question.
Cool. I'm going to draw some human little clients here that are accessing this application load balancer. And if you folks are going through the blog post, we're actually diving into a lot of details there. I personally learned a lot. I knew close to like 10% of all of this before I started. So much appreciated Pablo's and Satish's help on all of this. I feel like I've learned a lot, and I highly recommend you folks go tinker with it. It's so nice. I also learned how to use Kuro CLI in a really nice way to test all of these things out and to have it help me do all the setup. But yeah, go try it out. It's so easy and so straightforward. Okay, back to the presentation here. We only have 20 minutes left. I want to check in on you, Pablo. How are we with the demo?
It's ready. Kiro helped me fix the issue, so it's ready, so we can show it.
Amazing. Actually, I think this would be a good time to show it, and then we can continue with the slides, because I think it actually maps to exactly what I drew out here, which is really cool.
Kind of, yeah. I won't go much deep on showing. I'll show a little bit how it works, the demo and everything. So yeah, let's see if yeah, perfect. There it is. So, by the way, in the blog post that I published with Alex, you have a repo in GitHub where you can build this. So it's not that we're just showing it for this Twitch. It's that you can go take the code. You can see everything about how you can use the Gateway API controller for ALB and VPC Lattice, and how you can connect different clusters with different services. At the end of the day, it's like, it may seem in the whiteboard that there's a lot of things, but at the end of the day, it's easy. Like, you publish your services, you either publish them publicly through the ALB, as you see here in my edge cluster with my frontend and my backer for frontend application, or I do it through VPC Lattice in a private way. And then, of course, DNS does the magic, and now everything can connect to each other. By the way, DNS was the problem in the demo. Well, not real the problem. I was some issues on creating the DNS resolution after everything that I figured it out. So Kiro helped me figure that out. So yeah, it's always DNS. Well, it's always doing the proper DNS configuration rather than DNS. So as you can see here, like, I already have my 3 VPC Lattice services. That's back. That if I come back to the AWS console, I have 4 target groups that I created. This is kind of the nomenclature that the Gateway API controller is going to use. So I have my 4 target groups that are translated into 3 VPC Lattice services, and then 1 load balancer with a target group for my frontend. So then, of course, you can play with that if you build it up. So you can add items to the card. Also, you can see the headers. I think someone mentioned there, like, the seek before signing. It's the key thing of VPC Lattice. I completely agree. You can see here that once you sign your requests, you can have, sorry about that. You can have all the information about the principal doing the call, the org ID, the OUs that make that call, also session name that is more for traceability. But now you can create auth policies about granularity, about I want this guy talking with this guy only for some specific conditions. So I agree that this is the powerful thing. So yeah, so you can add items to your card. Then, of course, then you have access to the card service. So now we are just moving from one cluster to the other one to get the information about the card. And if we do the payment, you can see as now you can create this amazing cross-cluster communication where now my frontend is talking to another service, microservice in that cluster, but I need the card microservice to do the connectivity. So, and then, of course, you can see here the different hops. So this is the first hop from talking to the card microservice, and how the principal is the BFF pod, so the backend for frontend pod role. But if I go to the second call, I don't know if I can make it bigger. I think, yeah, I can do. You can see that the second one from payments is coming from the role from the card pod role. So it's not just showing it in the front end. It's really happening that I'm doing that. I'm doing that call. So yeah. So you can go to the repo. You can just build it up. It takes just a matter of minutes. I think I can go here quickly and show you that you will get like this manage.sh where everything gets built. And then, of course, you can go and check the manifest. So, for example, this is the ALB configuration that I'm doing, that my gateway now is LB controller with all the with the HTTP route, which is just a simple communication with the front-end gateway service. But then the VPC Lattice one changes a little bit, like same nomenclature, but now I'm just defining my VPC Lattice service network with my HTTP route, my custom domain name. And then I think this one is payment, so it's only have one target group. Of course, like for being VPC Lattice, you can add extra configuration, like the IAM of policy, which I'm doing an open policy. Don't do that in production. Like, always put like a really granular security piece. And then also the access logs. So you can also get all the access logs from the VPC Lattice services, and also from the VPC Lattice service network. Yeah.
Awesome. If you wouldn't know better, this is how Amazon.com is built.
Yeah,
So
exactly.
you have a front end, you have a front end, you have a card, you have payment, successful, one-click payment. Perfect. I use that all the time.
Yeah. I don't get the money,
Jumps.
but payments work. Yeah.
Exactly. I do want to clarify two things. So two super important questions that came up. Since payment is already exposed to public, so using the load balancer controller through the application load balancer, which is public. Puncher here is asking, VPC3 can access it through public gateway rather than the service network from the picture. Correct, but not actually. There's a very clean delineation between service-to-service communication over the private network and clients accessing services through your north-south Ingress load balancer, right? Ideally, you would have that clear delineation in your internal environment. Like, not all services should be exposed to the public internet. Services accessing other services shouldn't go through your internet gateway or the using public IP addresses. It's not the optimized path, and it's also not the most secure path. So having private communication between payments and card, for example, is really important, because technically payments is a service that does not have to be externally exposed, right? It's a service that just needs to be called by card, right? Card is externally exposed and you're fine. Or even in this case, actually just shop is externally exposed. And your footprint for securing this is essentially limited to shop and that public facing application load balancer, rather than exposing all these services to the public, using that gateways to talk to each other and having this suboptimal connectivity pattern. So really, really important. Even if the path is there, technically, like every service could access every other service using public IPs, it doesn't mean that you should use it. And it doesn't mean also that it's the optimized path.
Also, in these examples, backend A and B have no internet access. They're just like private communication thing. I put a couple of API endpoints to connect to ECR, but no NAT gateways, no internet access. So now, of course, it's like, hey, the only way to connect to payments is through VPC Lattice, where I'm not doing it, but you can put more granular controls. You have the access log, so you have the visibility from either the owner of that service or through the owner of the service network. That can be same person, different person, but you have all the visibility, and also you can have that extra control that otherwise you need to do through IP, and then you have the extra processing, extra infrastructure. This is like a much cleaner way and fast way to connect those services within AWS.
Yeah, that's perfect. Pablo, you have a question from X1 Autumn around what tool you've used to generate these cool diagrams. I want to know that too.
So it's, I have it around there. Like, let me see. I think it's React, and basically I just discussed with Kiro, like, hey, what are you doing, or what we should do? I put it in the documentation somewhere, so you have all this documentation public, so you can check. So it's React and Vite and Tailwind. And definitely hours and hours talking with Kira about, like, I want it this way, I want it this way. At some point, I discovered that it reads really well pictures, so I just did the drawing, put it there, and then it just like creates everything. So yeah, it wasn't Pablo, it was Kira, while Pablo was just like throwing random prompts around.
Nice. I love that. There's one super, super important question, and I would love for us to tackle it. How would you tackle external authentication via ALB using the authentication option and pass the authorization token through to Lattice? This is really cool because in ALB, if I'm not mistaken, you can add that header, correct? And then in Lattice, you can do authorization based on that header.
That's right. That's exactly right. Yeah. You could, like the auth header with the bearer token, you could use that header value and say, hey, authorize this or not, right? You could pass it from ALB all the way to the backend. We did one better too. Like you can, in addition to that end user auth header token, the JOT token that's in the auth header, right? And then if you're going from like a north-south ingress and then to a backend service in a different VPC or a different account, but you also want to make sure that the backend is only receiving traffic from authenticated Lattice services, right? Then you can say, things like we're going to add our SIGV4 signature on top of the auth header as well, and say we can add that to the query string. So when Lattice authenticates a service, you can be assured that your Ingress service that is terminating the ALB is the one that's talking to the backend, and nobody else can. That way you can lock that backend service down. And in Lattice, we're looking at both the auth header and the SIGV4 to ensure that it's indeed the Ingress sending it to it. And then in the backend, when we send it directly to the pods, then
I'm
send it to the pods.
Yeah, I'm just showing that, of course, like everything that you see here are the headers that the VPC Lattice receives, like that can read. It's not only the ones about the identity, you can get anyone. So for example, I included that one, that catalog, that I'm only using it to do the routing, but you can also use it to add like extra authentication. So hey, as Satish was saying, I want only this principal or this OU to talk with my service, but in addition, I only allow things coming from this extra header because I trust that this other my front-end microservice was doing the proper header manipulation to get the proper authorization and authentication of my users.
Yeah, that's great. And there's actually one more super interesting use case that I've seen quite a lot, and it actually ties back to what TechField is asking, like, why would I send traffic from ALB to Lattice? You wouldn't. You would send traffic from ALB to the shop pods, and then shop would call payments or would call inventory. The important piece is maybe not for this example, because like shop and pods and like shop and inventory and cart are not services that necessarily require the authorization based on the actual initial caller identity. But you have a lot of these, for example, when you have a centralized API gateway, right? One of our launch partners for Lattice was Kong, and there's a bunch of folks using Kong as their central gateway, like API gateway, and then Kong is accessing downstream services, right? Like downstream APIs that are registered through the Lattice service network. Now you would want to, and this is a super common use case, you have the caller get authenticated to Kong, right, or to your API gateway. And then whenever a downstream API is called, the authorization needs to happen, not that gateway, like that API gateway is calling API 1, right? Because it's not the gateway itself calling API 1. It's the gateway calling API 1 on behalf of an initial caller that called the API gateway. So you can do that authorization on that additional header with the token bearer or SPIFFE ID or SVID, to say, hey, the actual initial caller was Alex that is allowed to access API 123, but is not allowed to access API 758, right? And yes, Ken, different authorization levels. Exactly. It's essentially the first authorization piece on the front end, on the application load balancer. And then for whatever happens in the back end, you have additional layers of authorization that can be done on behalf of that initial caller.
Yeah,
pretty cool stuff.
To add to that too, Alex, like imagine you have a different Cognito-based user pool set up. So you can have users sort of segregated into different user pools and then have them authenticated with the different tokens that come back. And then in the Lattice policies, you could use those tokens to do what Ken, you're trying to describe, the different authorization levels, right? Like maybe user pools is one way to do it, or like other OIDC, OAuth2 based mechanisms as well.
Yep.
And then I think one other question, Ken, you had earlier that scrolled by was around VAF support directly on Lattice versus having to use an ALB. So today, VAFs have to be attached to something, right? Like ALBs or API gateways today. So we don't have direct support today. And I know we can't talk about roadmap stuff here. So the deployment, the pattern that I recommend is fronting that Lattice service with an ALB and using ALB as a target, and then doing all of your authentication, authorization, and stuff in Lattice, and then you're just forwarding it to ALB, and the backend target is registered to that ALB. So yeah, I know.
We
Yes.
have a PFR plus one. We have it.
Yes.
Noted. Cool. We have 5 minutes left. It's this session flew by. So exciting. I love the demo, Pablo. So thank you so much for joining us and talking about it today. Satish, I would want to go through one thing before we part ways, and we looked at the Gateway API spec for load balancer controller. So this is how things are mapped. We previously looked at the Gateway API spec for Lattice, the implementation for Lattice, which what is the gateway, what is the service, and targets. Exactly this one. We should absolutely have part two. Any parting thoughts? Any things that you want everyone who's been around with us? Quite a lot of folks today. We have a big audience on this topic, so I think we should absolutely do a part two. Anything that folks should take away besides what we have in our blogs and what we've talked about today?
I quickly wanted to focus on the controller itself, right? We are at the 202 release, and we have added a bunch of different things in that. And releases continuing. We plan to do a monthly cadence on this. So the cool thing to sort of look at in the 202 was the automated certificate discovery. So today, before the 202 release, what you had to do was to sort of take your ACM certificate arm and add that in the deployment manifest. Right? So you had to discover the certificate, and then when certificates got rotated, you have to keep updating those ARNs to sort of tell us, hey, here's the new certificate. Now use that for this HTTPS service that you're doing. But the feature that we just added was the controller goes and looks up the ACM based on your host name and tries to find the closest match, even one subdomain level matching that we support, to go and find the actual ARN. And it does that incrementally, periodically, so that you don't have to say, hey, keep adding the certificate ARNs to the deployment manifest. The host name itself can go and figure out how to sort of look that up and discover that. So things like those, where we keep enhancing those. So my request here is to keep track of 202 release and others, and then Alex posted the link to our GitHub repo, and add any issues you see, we're addressing them pronto, as fast as we can. And there's a bunch of cool features that are coming up on the controller too. So think of us, giving us feedback directly instead of the PFR +1. Think of this as a GitHub-based, feedback directly on the controller.
Issue +1.
Yes, issue +1. That's awesome. Cool stuff.
Yeah. And we'll do a deeper dive on, I had a couple of slides on how the controller itself works. How do we reconcile? How do we, improve the speeds? And today we have the grace termination periods of less than 60 seconds. And pre-stop hooks should be no more than 15 seconds. So this speeds up your blue-green deployments or rolling deployments or canary deployments. And we also support with Argo, and Argo rollouts with the Gateway API spec is supported. So there's a bunch of blogs we can share, and we'll send that over, or please reach out to us, and we're happy to share all the different content. And Ken, you also asked a question around the deployment, the examples of what I was describing earlier with the dual authentication structure. Right? So happy to share those blogs with you.
Yeah, that's awesome. We are right on time. Thank you all so much for the time today. Thank you for the amazing session, and see you next week.